Okay, welcome to Astronomy Lab 1. This first lab is going to be a math lab, so we could get acquainted with some of our mathematics. And so let's talk about the scientific method in general. You've probably had other science classes where we kind of follow this pathway of asking questions, looking at background, constructing a hypothesis, analyzing it and kind of looping back around. So a lot of times in astronomy, things are not that linear. A lot of times we just kind of look and see what happens, and then we might form a hypothesis. So as we're going through this semester through some of the labs, we might not exactly follow that exact method. So let's look at this math here, and the best way to actually do this is really by practice, and that's really what this first lab is. There's quite a bit of calculations. A lot of the other labs won't be as heavy with mathematics, but this first lab is kind of just geared to help you get some practice. I don't know how long it's been since you had a math course, so just to kind of get us reacquainted with that. So calculators are going to be allowed. As far as using a cell phone, make sure you check with your instructor to see how they feel with that. I don't know the policies at Browning High School, so make sure we follow up with that. But typically, we use an app is fine, or just using the regular calculator would be okay, the regular scientific one. So let's look here at formulas, and I got a little ahead of myself here, so let me just go. So looking at this one here. So let's do something simple to kind of acquaint ourselves here. So maybe something solving for A equals B times C, and we want to solve this for B. So, going through the motions, you've probably heard we divide both sides by C, and then that'll give us, so right here, dividing both sides by C. This will kind of get rid of these here, right? I don't want to use the C word, cancel, right? Kind of a bad word there. We don't use the C word here. And then we'll have AC is equal to B, and we could kind of rewrite that. So just to be a little bit more formal here, and this will kind of help us as we're doing convergence as well, is we call this the operator, right? Multiplication is an operator. And we want to think of the inverse operator, so kind of the opposite. And so that's going to be division. And so when we solve something, we do the inverse operator. And in this case, for multiplication, it's going to be division. And we don't really want to think of this as, again, the C word here. What's happening here is that we actually end up with C over C. This really becomes 1. And so what's happening is you end up with something times 1. And when that happens, well, it's just that something, right? Or B times 1 is just going to be B. So it seems like it magically disappears, and they use that, cancel out term. But we're really working it out. We're trying to kind of get that inverse operator. And so it's helpful sometimes if you have a formula, before you start plugging things in, you might want to be able to solve for every variation. So even if we have something like this, maybe we want to solve for C in this case. And we could kind of go through the same motions here, and we would see that C is also equal to A over B. So from this one equation, we could have A is equal to B times C. We could have B is equal to A over C. And we could also have C is equal to A over B. And now we have all variables solved, so different variations here. And a lot of times it's just helpful to just have these up front, and then we could just kind of plug and chug. Some other formulas we might use a bit often are averages, and I wanted to stay away from the formal kind of notation here with our you've probably seen a summation notation like this here for a mean perhaps, but we're just doing an average. So if you have a few values, for example, let's just say we have 3 exam scores, you got an 80, you got a 70, and you got a 90 here. And so you add them all up, and then we divide by the number that we actually have in this case. So 240 over 3, and that's going to give us an average of about, but exactly 80 there. So finding averages, adding these up, and then dividing by the number of values that we have there. Percent errors is just kind of finding the difference and then dividing it by typically the original amount, or what we sometimes call the accepted value. So for example, let's say that our accepted value, we know it should be something like 5. And then we actually do some experiments and we calculate, and we get something like, let's say, 4.8. So pretty close, but not exactly. So we want to know, like, well, how far are we, right, from that? So we get our calculated value and we subtract the accepted value. And then we're going to divide by the accepted value, because that's kind of the original amount, right, what we're trying to compare it to. And so if we do this, we will actually end up with negative 0.2 over 5. So let me just work this out real quick. This will give you negative 0.02 over 5, which at the end gives us a negative 0.04. Whoops, and let me correct that, not 0.2. That should just be a 0.2. There we go. Okay, so this is kind of telling us how far off we are. And the negative really just has to do with the direction, like are we above it or below it? So a lot of times we don't really want to mess with that. So that is why we do the absolute value of it. And so if we do the absolute value of this, then we could kind of forget about that negative symbol. And so that's going to end up with just 0.04, right? And it's a percent, so this is kind of what we want to multiply by. If we multiply this by 100, then we're going to end up with, again, it's like moving our decimal 2 places, if you want to think of it that way. But we'll end up with 4. And if we want to talk about it in percent, it would be a 4% error in this case. So another helpful formula that'll help us to calculate these kind of percent errors. How close are we? How far off are we? And that helps us out a lot of times with our instruments, right? How accurate are our instruments? A few other things here. Scientific notations. Your calculator might write this in a slightly different variation here. So let me go, if I could pull a picture here from, calculator input. Here we go. So if I put 0.00005 in my calculator here, it's going to show this notation of 5e negative 5. So that e just means times 10, and then it's to the power of negative 5 in that case. And that's what I wrote down here. So 5 times 10 to the negative 5, and you see it spits it back out as 5e to the negative 5. And it's just compact notation your calculator will have. So if you do see those, that e notation on there, just know it's writing it in a scientific notation. That double E typically looks like that E looks like a double E on a calculator, but when you press it, it comes out as a lowercase. Okay, so really big, really small numbers, scientific notation is helpful, but your calculator might write it slightly different. So let's do a small conversion here. So we want to convert 1 inch into, or 6 inches, let's say, into centimeters. And we first have to have a conversion factor. So we all know 1 inch is equal to 2.54 centimeters, right? And so if we wanted to convert 6 inches to this, let's think about this. So we start off with what we have, so 6 inches, and I'll use IN for inches here. Now, what we're going to do is we're going to multiply this, but think of that inverse operator that we said. I want to get rid of inches, right? So I'm going to put inches here in the denominator, the same way when we did that one problem where we had C over C gave us a factor of 1. Well, that's kind of what's happening with units. Think of it that way. Inches over inches will create a factor of 1. And this is what we, sometimes say as, oh, it's going to go away, right? Inches are going away with inches. But we're really creating that factor of 1. And so that's how I know that I want to put inches in the denominator. So therefore, I got to put centimeters up on top. And I'm just going to use my conversion factor. So 1 inch is 2.54 centimeters. And if things are on top, we multiply. If you had a number on top, here and one on bottom, then we would end up dividing them. But we're going to go ahead and just go straight across here. And so this would end up giving us is equal to 15.24. And again, these are going to create a factor of 1. And then we're dividing by 1, which we don't need to write. So my only units left over here will be centimeters. And if we wanted to do double conversions, so looking down here, again, inches on top. So I need inches in the denominator. Then centimeters in the numerator, so centimeters in the denominator, creating those factors of 1. And my only units left would be millimeters if we wanted to go all the way into millimeters there. Okay, graphing. We're going to do a bit of graphing also. A few labs will consist of graphing here. Now, this is a little bit differently from an algebra class. Typically in an algebra class, when we do our x and y axis, right, when we start plotting these, our points always end up being a straight line, and then we always end up connecting that line, right? This is not what happens in reality. This is more kind of in an algebra textbook, right? In practice, we get things that are a bit more scattered. And so you get real data that tends to kind of look perhaps scattered a bit. But there will be an overall trend. We could say, hey, this kind of looks to be increasing, and we try to find the best line that'll fit there. Really what we're doing is the line that is collectively least furthest away from all points. So we get the distance from every point to each of these lines here, and we get the average of those distance. And the line that has the least amount of distance collectively is what we call a line of best fit. And so we'll kind of look at that afterwards. But just to kind of get a sense of scale here, so don't think these points should always line up, and we don't always race to draw a line through it. Sometimes we'll just leave our data as dots, as data values. And as you're going through the labs, again, make sure that you answer all the parts. If there's A, B, C, D, it's referring to the problem before. Okay, enjoy.